Looks like I can go. All right. Ratios. Many of you are probably familiar with a ratio that looks like this, 3/4, 3/4. Please get used to, in this unit, starting to see this a little bit differently, where I put the colons in instead. Just know that these two are the same exact meaning. All right? 3 to 4 with the colons is the same as 3/4. All right? You will see that a ton, especially when we start the proofs. All right, I just want to make sure we can write our own ratio. All right, I gave you a little example of a scale model of a car and an actual model of a car. The scale is 14 inches and the actual is 15 feet. What's the ratio of the model to the length of the car? Two things I want to make very clear here before you write your own ratio. Order matters. Order matters. I've asked for the length of the model first and then the length of the car second. Second thing that's important, needs to be same units. If you're going to do this, can't have this, 4 to 15. Because I'm assuming that's the same units, which we know it's not. This is 4 inches, and this is 15 feet. So we need to convert one of them right now. And that's up to you guys. Whatever, I have an idea what you want to convert, but you let me know. Inches to feet, feet to inches. Inches to feet, feet to inches. Which one do we want to do here? You want to make it all inches? Fine. So I'm keeping the 4. And that means you guys got to help me out, convert 15 to inches now. 15 feet, how many inches? What are you doing with the 15? Multiplying by 12. Good. So how many inches in 15 feet? 180. So I can have 4 to 180. Remember, I can also have 4 over 180. All these mean the same things. I would just be aware, sometimes you may have to reduce. I'm not going to ask you to do it right now, but sometimes you may have to reduce it. All right. Questions at all? All right. Now, when I put 2 of these equal to each other, I end up with what's called a proportion. How do you guys solve proportions back in the day? Cross multiply. Perfect. All right. And I just want you to be aware real quick that you guys are probably so used to having a ratio equal to another ratio, but you can have 3 of them or more. That's called an extended proportion. All right, when 3 or more of the ratios are equal. My goal with you today is solving these proportions. I'm starting very, very basic and then getting a little bit more hardcore after that. So let's get basic on number 1. You guys said, how do I solve this proportion? 2 ratios equal to each other? Oh, cross multiply. Thank you. Yeah, cross multiply. I'm not even going to pick any numbers here. Don't need to. 5n equals 70. So n ends up being 15. Okay. Number 2, I don't know if I stepped it up or not, but what do I have wrong?
14, not 15.
14, huh? I think one of my classes just left me leave it 15. This next one, I'm not really stepping it up, but what are you doing with the 2 and the x plus 1? I know you're multiplying, but what do you have to do with the 2? All right. And I just wanted you to be aware of a common mistake I usually see. Right here. This is what I usually say. Distribute once, but not to the other side of the addition or subtraction symbol. Okay, so watch yourself. Plus 2 equals 3x. Not a big deal here. X equals 2. Did I get that one right? All right, good. All right, now we can have some fun. Now we can have some fun. Right away, I mean, that's not a proportion. X plus 6 is just there. It's not a fraction or a ratio. What's actually there that's not showing, but we can still cross multiply? You're darn right. Over 1. All right, so here we go. X plus 6 times x minus 6. Remember those days? I am not a big, just so you guys know, I am not a big fan of the term FOIL. I will refer to that as double distribute right now. Okay, I have my reasons. All right, I'm not a big fan of the FOIL term. So double distribute, and then we'll talk. It'll come out to be in a second. Yep. What do you end up getting here? X squared minus 36. Does everyone see the 6x and the negative 6x simplify each other? And then you're left with 13. All right, now I'm going to turn this over to you because there are two different directions we could go. I'm going to turn it over to you. Before I turn it over to you, you may have not been told this last year, but this is huge knowledge right here. Power. What is the highest exponent right now showing in this equation? A 2. Whatever the highest exponent is, that's how many answers you should have at the end. Okay, little tidbit for you. Pretty powerful. You can take next year to Algebra 2 as well. Whatever the highest exponent is, that's how many answers you should have. So at the end, we're going to have 2 answers, whether you have it or not. All right, 2 answers. What do you want to do from here? I'm going to turn it over to you guys now. What do you want to do from here? Here we go. 7. What do you want to do from here? Got to get x. Got to get solved for x.
Could you get it down to x equals something and then substitute that again? No? I don't know.
Solving for x.
Oh, add 36.
Okay, you want to do that? That's fine. That's one way. Here you go. Doing the Jeff way here. Add 36. Fine. I'm going to do it differently at the end, but I'm going to keep trucking. X squared equals 49. Everyone's good? All right, how do you get rid of the squared? Square root, and here's my worry. Done. How many answers were you supposed to get, though? 2. You only got 1. Why? Because when you take the square root, you're left with the positive version and the negative version. Yes, so please start watching out for that if you do it the way Jeff prescribed here. All right. Are you familiar with this little symbol? Plus or minus? Okay, because that's how I'm going to write it from now on. So please be aware of that. Highest exponent's 2. I should have had 2 answers. Now, the other way to do this is to factor. And you cannot factor unless one side is what? Equal to 0. So instead of moving the 36 over, move the 13 over. X squared minus 49 equals 0. This is a method I have yet to talk about this year. But you've done plenty of it last year, I hope. How many terms are there? 2 terms. You know anything about 49? It's called a perfect square. Yep. This is the difference of 2 perfect squares. Maybe you called it dots for short last year. Dots. I don't know what they're teaching nowadays. All right. Difference of 2 perfect squares. 49 is a perfect square for what number? So 7 and 7. Do you guys remember anything about the signs last year? Always opposite. Always opposite. And then that's also the other way we can get those 2 answers out of 7 and negative 7. All right, so we could have went either way there. All good? Anything you want to ask here? Again, I'm trying to take this a little slower because I know I'm not going to have time to review it during the unit. All right. Here we go. Let's get our factoring belts out. Go ahead, cross multiply. Everyone have x squared minus 2x equals 5x plus 30. We're all good there. What's the highest exponent in that equation? 2. Keep reminding yourself. So I'm going to have 2 answers at the end then. All right, 2 answers. But this is not like the last problem where you can just move things over and square root. That's not going to happen here. So I am forced to factor. One side needs to be equal to 0. So move the 5x over. What's it become on the left side? Minus 7x. And move the 30 over. It becomes minus 30. This is what I've asked you guys to deal with all year long. So hopefully this isn't a shock. Okay. I will go over it though. All right. Even though I know most of you coming from your tests and quizzes know how to handle this. How many terms are there? 3. And do you guys remember there's an A, a B, and a C term from these? All right. What's my A term here? The number out in front of x squared. 1. So when there's 3 terms and the a value is 1, that's when you play the little game with yourself and you say, all right, 2 numbers that multiply to c. What's my c value up here? So 2 numbers that multiply to negative 30, but at the same time, add to b. What's your b value? All right, so can we think of 2 terms, 2 numbers multiply to negative 30, but it'll give me negative 7. I always start thinking about the multiply first, always. I start going in my head, all right, 30 and 1, 15 and 2, start narrowing it down until I can get a 7 somehow. Got the numbers, Lauren? Go ahead. They multiply to negative 30, yes. Do they add to negative 7? Yes. And then from here, my 2 answers, x equals negative 3 and x equals, bless you, 10. 2 answers, just like we predicted, because the highest exponent was 2. Do you want to try 2 and 3 out on your own right now? 2 and 3 out. I'll give you guys about 2-3 minutes. And then number 4 is a little bit different type of factoring we got to talk about. I'll leave my work up here so you can check it as you go along. Two numbers that multiply to c and add to b. If you're getting frustrated right now, all right, make sure you come on in here, all right? I can give you a slew of these to practice from. But today's the only day we can review it, remember. You know best if you struggled with this last year. Two numbers that multiply to 12, 4 and 3, and they have to add to negative 1. X equals negative 4 for this one, and x equals 3. This one down here, what were your 2 numbers that multiplied to 20 but added to 1? Plus 5 and negative 4, yep. So x equals negative 5 and x equals 4. All right. Any issues with that? All right, you ready for a little new type that I have not discussed this year, but you have You saw it a ton last year. Go ahead, cross multiply if you haven't done so already. We're going to get 3x squared, and that's going to be equal to, looks like 30x. All right. Guys, what's the highest exponent? Okay, so we know at the end we're going to get 2 answers. All right, that's what I need your help on, is finding those 2 answers. There's no square rooting here. There's no dividing by here. So I'm going to make one side equal to 0. And I always love whatever's with the x squared, try to keep it positive. Always love that. So I'm going to move over the 30x. Is this 3 terms? No. So you can't play the whole multiplies to this, adds to this game. Are these perfect squares at all? Nope. So it's a method we have yet to discuss. And this is a method you guys probably called GCF last year. What do they have in common? So out of 3x squared and 30x, what do they have in common that I could maybe divide each of them by? Okay, a 3. More, because then you got to look at the variables. They both have x's, so I take out the one with the lowest exponent. 3x, you are correct. I can take out a 3x. When I do that, in parentheses, you got to tell me what's left over. So I had 3x squared. I just took out a 3 and an x. What's still left? The x, yes. It's kind of like reverse distribution. That's what this is, reverse distribution. 3 goes into 30 10 times, and I have already taken out the x, so I won't put 1 with it. Okay, right away, you guys know what one answer is. X equals 10, but you told me how many answers? 2. Where's that other one coming from?
I have a question.
Sure, go ahead, Jeff.
Why couldn't you divide by 3x?
Okay, if you do divide by 3x, that's fine, but the 3x is still part of the factoring. Like, if you divided by 3x, I'm afraid you're just going to do that. And you're going to forget an answer, because remember, there's 2 of them here. So yes, you can divide by 3x. I am fine with that. But the 3x has got to stay, though. Good? Where's that other answer come from? Your GCF. You also have to set your GCF equal to 0 and solve. That's where the second answer comes from. So how am I going to solve for x here? Divide each side by 3. Yep. So x equals 0. So you have 2 answers, 0 and 10. And if you went back and plugged in 0, you would find that both sides would equal 0. Right. So is everyone all right? I get that second answer. Set your GCF equal to 0. All right, well, what if you can't factor? It's impossible. Or let me rephrase that. What if you don't want to factor because you think your factoring game's poor? Is there another option? And the answer is you're darn right there's another option. But before we get to that option, I want to make sure you can simplify a radical. Because yes, a lot of you are already piping up quadratic formula, quadratic formula. What's quadratic formula have in it? A radical, a square root. So we need to be able to break one down before we start using the formula. And you guys, how many times have we done simplest radical form this year? Almost every time I can, right? Just trying to prep you for Algebra 2 next year. 72, you're looking for the biggest perfect square. Biggest one, not the first one you come across. The largest one that goes into 72. And again, perfect squares. And some of you may say, oh, you're a math teacher. You know those already. You memorize those. I don't memorize them. You know how I get these numbers? 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. That's how you get those perfect squares. It's nothing you guys should ever have to memorize. Okay. Biggest one that goes into 72. 36, how many times? Twice. You pick a perfect square for a reason, to take the square root of it. Square root of 36. 6. Hey, that's a different number than what you just told me. 6. Radical 2. I always see people just do something like that. It's 6. 6 is different than 6 radical 6. 32, let's do the same thing. Biggest one. Might not be the first one you come across. Mike? Yep, go.
Do you have to put plus or minus 6?
No.
Okay.
Nope.
I had the answer
16, thank you. 16, how many times?
Twice.
Twice. 4 radical 2. And here's why you don't put the plus or minus, Mike. If you did put the minus, what's a negative times a positive? But I had a positive square root here, so that's why. Okay, good question. Okay, why am I going to ask you now to divide? Anybody think of the quadratic formula? What's it all over? 2a. So I need you to handle simplifying it and then maybe simplifying again by dividing by 2. So here you go. 48, go ahead. What's 48 going to break up into? And notice I'm picking ones that have a bigger one than the first one you find. 16 again times 3. So that's going to reduce to what? 4 square root of 3 over 2. Can you keep reducing? The 4 and the 2. Reduce down to 2. Yeah. So this ends up reducing down to 2 radical 3. I'm sorry, I apologize at the beginning. I should have noted can't divide these. It's not 24. Because remember, is this 48? No, it's some decimal, whatever the square root of 48 is. So you can't divide them. And then what about the square root of 150? Because I can't divide those. Biggest perfect square? 25. I always think of it this way. If you have $1.50, how many quarters do you have? Right? 6 quarters. What is he talking about? Quarters. Who uses quarters? Do they even have any arcades around anymore? Or is that too old school? Just go to your Xbox and your PlayStations. All right, whatever. Sorry, I brought it up. I'm old school. Sorry. What can we simplify here? Yeah. Questions from you guys? Because I got to pick up the intensity right now. There's your quadratic formula. I got good news for everyone. Hold on, I got good news. You guys remember for your algebra readings last year, you were given a reference sheet? That's on there, right? And because it's on there, any test or quiz we have on here, I will give you the reference sheet so you do not have to memorize this for me. Not why bother if you're going to get it on the Regents, right? So you will always have this given to you. The part underneath, have you talked about last year? The part underneath the radical is called the discriminant. All right, we're going to use that right now. You know the answer. What class are we in? Honors. So if you guys can factor it, we're going to factor it in here. Whether you're factoring games at an A or a D level. Okay, because this is an honors level course, if I can factor the darn thing, yeah, we're going to factor it. And some of you may be like, factoring beast, let's do it. All right, and I get that. But sometimes you're going to look at a quadratic and say, ooh, can I factor that or not? And I don't want you spending 5-6 minutes trying to factor it. There is a way to know, like that, if you can factor this or not. And that is by using the discriminant. And let me show you how you can use the discriminant to see if I could factor this or not. You guys told me you knew what A, B, and C were. So what's the A value here? 2. How about my B value?
1.
Negative 1. And my C value? Negative 15. You can take the discriminant, plug in your B, A, and C value, and you'll get a number out. I'll talk about that number when we find it for this particular problem. But whoa! Hold on. I do not want to see negative 1 plugged in, 2 plugged in, and negative 15, and you guys trying to figure that out. Love you some store button, please. All right? You cannot get the discriminant wrong if you utilize your store button. All right? And I think I talked about this, second day of school? It's been forever. What was our A value? 2. So I'm going to take 2, store it. Everyone see the letter A above the math button. So alpha math. Store it in for A. What was your B value? -1. Store it in for B. C value was -15. Store it in for C. Tell your calculator, please compute what B squared minus 4AC is. Ready? B squared minus 4AC. Whatever numbers you've already stored in there are going to get stored into that one. Yep.
Mine's not working. I'm hitting the store button. Then I'm hitting 2.
No, you got to hit the number first, Mike. Number, then store. Number, store, letter. And then what are we getting in and out? 121? 121, everybody? So the discriminant is 121. How do I use that number to see if I could factor? You ask yourself, is it a perfect square? Is 121 a perfect square? And I bet half of you know, half of you don't know, which is fine. How can I figure out if it's a perfect square? If you can take the square root of it. Can you take the square root of 121 and be an even, but a whole number, no extra? Yes. So what that tells me, because the discriminant was a perfect square, if I wanted to, which we definitely will in here, I could factor that. Right? So this is factorable. I'm not going to factor it because the question just asked to tell if it was factorable or not. If the discriminant comes out to be a perfect square, it's factorable. Love me some store button. All right? Love it. You can never go wrong. Figure out right now on your own, is the next one factorable or not? Use your discriminant to see if it's factorable. So find your A, B, C, store those in. What are you guys getting out as far as the discriminant goes? 200 and? And that's even above my level there. I have no idea if 241 is a perfect square, so I would have to go to the calculator, square root of 241, and does it end up being a whole number? Nope. So we're going to say this was not factorable. Whoa, 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 not done here yet. So if you couldn't factor it, how would I solve for x then? Let's do it. All right, let's use the quadratic formula now on a different quadratic. Are you familiar with this term from last year, roots? Solution, zeros. Anybody else got a fancy name for it that was used last year? If not, that's fine. We can end it there. The only one I could think of would be x-intercepts, but we're not going to get that hardcore. A value, what do we got, guys? A value. 1, B, 2, and C. Okay. I'm just going to force you to use quadratic formula. You may think you can factor it or not. I don't know. But I want to just use quadratic formula so we're comfortable. So x equals, if I plug in -b, what's that 2 going to become? -2 plus or minus. Again, you know what you're going to see? A blank radical for me. I'm not going to do b squared minus 4ac. Love you some store button right now, please. Go ahead. Find a discriminant. There's no need. And yes, every couple of years I get a kid, oh, I'm going to show him. I don't need my store button. Okay, fine. Go ahead. I just hope you don't get confused with those negative signs. If you want to try to beat the system without using your calculator, go for it. High fives all around. What are you guys getting for your discriminant? 8. So could I have factored anyway? Even if I wanted to, could I have factored it? No, why not? 8's not A. Perfect square. 8, done. All over 2A. And make sure it's all over 2. I kind of see people pull up right about here. I don't know why, but it's all over, bless you, 2A. Do I want the answer left like that? Why do you think I just went over how to do this business here? Okay, we're not leaving it there. Simplest radical form. So go ahead, break down 8 right now. Perfect square, that goes into 8. 4 times 2. All right, so it break -2 plus or minus. What's that break down into? 2 radical 2, yep. All over 2. You know you can do something. You're just like, what can I do? There's just so many 2's. And I don't blame you. See the denominator too? It gets applied to both sides of that plus or minus. -2 over 2. Yeah, but it doesn't disappear after that. What can I reduce there? The 2's here. And what am I left with? Plus or minus? Radical 2. So please remember that denominator applies to both sides of the plus or minus. It does not go away after you divide it first. It's still there for the second one. All right. Yes.
When could you not divide when there was a radical?
Let me do a couple other problems, please. Okay. Thank you, Bella. Let me teach the show here. Questions. By the way, what was the highest exponent up here? 2. Do you see how you have 2 answers here?
Yes.
-1 plus radical 2 and -1 minus radical 2. Good. Let's roll. We're almost finished here. Home stretch. Find the roots, find the solutions. I'm not going to do that unless one side is equal to 0. So 3x squared, put the 5x where it should be. Is that a -1 for you guys? Yes, -1. Remember what I said? If we can factor, we're going to in here. I don't know if we can or not. What's a quick check to find out if we can factor it or not? Discriminant, discriminant, discriminant. What's your A value? 3. B value? -5, and C value? -1. Now, I say in here we're always going to factor. That's when you do your homework and test quizzes, that's a personal decision. If you want to go right to quadratic formula, fine. All right, if you want to show off your beastliness, go ahead. Discriminant? What is it? 37. Are we going to factor this? We're not factoring this, right? Because that's not a perfect square, so we're forced to use what to solve? So forced to use quadratic formula. Oh, this is the best part of the lesson coming up. Best part. Ready? Okay, quadratic formula to solve. X equals -b, but it was -5. So 5 plus or minus. Oh, hey, take a look. We just did the work. Are you going to restore again? No, you know what goes underneath. What is it? So it's good to do the work ahead of time to figure out if you can factor, right? You didn't do it for nothing. All over 2 times 3, 6. All over 6. All right, going to Bella's question. Mike, go first.
Are you going to force us to show all this work? Because last year we just typed it all into our calculators.
No. What do you mean show all this work?
Show the discriminant and then show you solving that on the right.
No, I don't need to see the discriminant at all, but I am going to ask you to do this and then anything simplified, yes. It's going to be very rare that I ask you to round to a decimal. Okay, so if that's what you mean by plug it into your calculator and get a decimal, I'm not going to ask that. Okay, but no, I don't need to see this, no. But I at least need to see this stuff right here. Okay? Going back to Bella's point, can you break down square root of 37? Can you simplify that at all? Yes, no? No. Can you do 5 over 6? Anybody simplify that? I can't. So guess what? This is it right here. You can't go any further. You can't simplify the radical, and you can't reduce anything. That's as far as we're going. Okay. Everyone all right there? That's as far as we're going. What do we have? Another one? Okay, your choice. I'm going to let you know you have a choice, but it's going to end real quick. X squared plus 5x equals -2. X squared plus 5x plus 2 equals 0. So, you know, like in this problem, I think some of you, can you tell if you can factor or not? Like, do you know two numbers that multiply to 2 and add to 5? We're going to be here a while. Anybody? We're going to be here a while. All right, so that automatically knows you're not going to be able to factor it, so go right to quadratic formula then. Negative b would be what? -5 plus or minus. Guys, I'm going to save you time because I want to finish this problem. Square root. I just forgot. $17 when you store it all over. What should it be all over? 2. Okay. Stay with me, please. Don't pack up here. Can you break down the square root of 17? No. Can you reduce any of these here? No. So again, just like the previous problem, we're done. Hold on a second. Hold on. Is the bell going to cut me off because I may have to go this Monday? Let's find out. Is that really a 6? Oh, one more minute with this guy. Here we go. Let's say, don't write this down. Let's say it was -6. Let's just say that was the answer. It's not. Please don't copy it down. And you're like, hey, I can reduce that. True. -3, right? But remember what I said before. This 2 gets applied to both sides, doesn't it? So it's not going to be plus or minus radical 17. The 2 is still there on the right side. So how would I write it? Radical 17 over 2. Okay, so be aware of that. All right, just because you can reduce one side doesn't mean it's done. Nice job today.